Okay, I think we can start. So, hi, I'm Martin Benz. I work at Shopware. Maybe you can see that. And I want to talk with you about AI today. Like a lot of people, likely most people on most stages in the last couple of years. And but we are doing this a bit different today. We are going one level up or one level down, depends on how you want to see it. We are going on the meta level. So, this is what the usual timelines currently look like if you are vaguely interested in any AI topic. So you have like the 10 top Claude code tricks, you have the best AI tools for whatever year, whatever purpose you name it. And of course, things like I built a tool that codes while you sleep. So you've seen this all, and to admit it, I've clicked some of this clickbait as well. None of this is wrong, exactly. They just all answer the same question, which tool you use. And that answer basically changes every couple of weeks by now. And if you stick with that, you have to start every couple of weeks over. Because what you've learned a month ago might be obsolete about your favorite tool because someone had a better idea and made a better version of it. So, and we will start with these talks underneath all of that. We're doing this in two parts. The first part, we will talk about the engine that fires that all up. Don't be afraid, I won't go into the mathematical details or things like that. And then we'll talk about the practical part. So I will try to give you the hands-on mental model to handle your day-to-day work and to be not dependent on any specific tool. So once you understand the engine and master the practice, the specific tool will stop matter for most things because you can swap it out. You will be able to create a new one that just is better tailored for you and your maybe updated requirements for whatever you can imagine. So let's start about what you are actually talking to. When you're using AI, or large language models, you're not talking to Claude or you're not talking to ChatGPT either. These are just characters. So the thing performing the character is an engine that does nothing more than turning text into more text. But the science behind this is very complicated. As I said, I won't go into the mathematical details of transformer models. Let's keep it like that for this talk. An engine is the thing that turns text into more text. So this is exactly the level we need for the understanding here. The engine itself is basically a puppeteer, and for example, Claude is a puppet on its strings. So when you're prompting, you are not persuading a mind, but you are shaping the input that drives the engine. So it's important that you understand it for your own mental model. And every lever you have to specify and form the output is actually a lever on the input. So, and one side note about the engine, you might have come across the strawberry check. So you or others have asked the model to how many R's are in strawberry, and sometimes it fails, sometimes it succeeds, and it's often misconcepted as a scale for how smart an AI is. It is really not. So the large language models act on tokens and not on specific characters. So they miscount the R's in strawberry and fumbles in rhymes and anagram. So that's actually a representation gap and not stupidity. So don't trust a large language model with character level work. Either you have to spell out what to do, or you give it the proper tools to work on the character level. So, and if it's the engine that's performing as a character, how does a conversation actually look like? The model has no memory between turns. So a turn is you give a query and you get a response. Instead, on every turn, the whole conversation so far is resent and reread from scratch. Let's watch how this happens. So we have turn 1, and we have turn 2, and turn 3. And as you see, the conversation grows larger, and also the costs will rise. The conversation is actually the context of your whole session of what you want to do. So there's no hidden state in this, and in every turn you pay for it all. There are mitigation techniques like caching, but they are only that, mitigations. So in the end, it stays the whole conversation is the context of what you are currently doing. So what's the thing that does all this rereading over and over in a loop? And there we come to the word agentic. Just to give that forward, the word is used for many different purposes. It's by now a marketing term as well. But in a simple case, an agentic is just a word for loop. So that means that a large language model is able to basically feed itself with the help of something that surrounds it. And that's what we can call an agent. So the model proposes, based on your query or based on your initial prompt, an action. The runner executes it, the results come back, and the model reads the result, and then round it goes. And this goes until a final answer is given or some abortion condition is met. The runner does more than press buttons. It assembles everything the model reads, it executes the tools, and it feeds the results back. This is, like I said, the agent. And I will keep describing it like that by what it's doing and rather pointing to any specific product or promoting any specific product. So agentic is more like a property of any runner that is capable to communicate with large language models. And it's not the engine, because the engine still does only turn text into more text. So how does this agent assemble the context? So everything the model reads lives in one place, the context window. So your question goes in, the doc you pasted goes in, and they land on top of a base that was already there before you typed anything, and the base that you don't even see. So what this base is, we will come to that later. So, and then the conversation runs and the window fills up. With the file the agent read, the tool output, the answer of your next question. The runner I showed in the last slide assembles all of it into one pile. And that pile is finite. And what's in the pile actually steers the answer. So if you ask, how should I structure this next to a greenfield prototype, you get something like move fast, one file, and skip the tests. So fast results, fast prototyping. If you ask the same question inside a regulated production code base, like Shopware, the question didn't change, but the answer does. It's more like something like a layered, tested, and reviewable approach. So the window around changed, and that changed the answer, but not necessarily without you seeing any of this. So you could ask, why not just assemble everything yourself, put everything into one prompt, attach everything? You've seen all the symptoms of the underlying problem. A long session where it starts to lose a thread. It ignores things you already told it. It's forgetting things it already knew, supposedly. And that is not the model being moody. that is the cause of two effects, the result of two effects. The first effect is position. That was too fast, sorry. The first effect is position. The recall is high at the start of a context window, and it's also low at the end of a context window. It has problems in the middle. So, and this is known creatively enough, the lost in the middle problem. And it's the reason you put what really matters the most at the edges. This can be your important documents. This is, of course, your initial prompt. And on the other hand, it's what currently matters the most for the task you're doing. The second effect is length. There was once a benchmark done where a single relevant fact was hidden inside a context window. And it was measured how often the model could find and answer with this fact. There was no keyword overlap to latch into for the model, and the model had to actually read its own context. With a short context, ChatGPT 4.0 or GPT 4.0, so it's a while ago already, got 99 times of 100 times correct. So pretty good. If the context was blown from the point of view back then to 32K tokens, that already dropped from 99 to 70. And most models were acted even worse. They were tested, and when they were out of their short context window, the accuracy of the answer often dropped below 50% of their initial score. So the usable window in your model is much, much smaller than the number that is usually advertised. So you should be aware of this. If you're using a model that allows 100K token, 200K token, a million token, you should never go anywhere near this. So, and there's a word for all this, context engineering. It's deciding what goes into the context window, what stays out, where it sits, and in what order. Because the same pieces in a different order give a different answer. Yeah, the position, the length, and the order are the levers here. And the most efficient lever of it all are the words themselves. And this brings you to a concept that is not that commonly known. On the right, you see behind the boundary a cluster of knowledge the model already holds. And that's even before you prompted any word. So some terms act as anchors. So if you say in your prompt something with TDD London School, you pull the whole cluster, outside testing, mock-heavy, interaction-based verification into your response, into the whole processing. It's the same for clean architecture and also for solid. So you invoked a whole framework of knowledge in just 2 words, or even with less than that. And that's what's called a semantic anchor. In the prompt engineering sense, also this term is used different in other fields, but you will actually find it if you Google it or ask any model for information of it. You can use semantic anchor. So let's have a look where these things live. The words you wrote, like solid or TDD London School, they live in the context, and it's like 5 tokens, so extremely cheap. But the knowledge they pull doesn't sit in the context at all. It lives in the model itself, and specifically in its weights. So this gets a bit technical. So what is a weight? There are billions of numbers inside any model. They are also called parameters. The training of the model tunes these numbers and everything the model picked up along the way, and ends up encoding across them. So once the training of a model ends, these numbers are fixed. So the anchor doesn't teach the model anything new. It points knowledge that it's already there. And that's why anchors does so much work. You pay context for the key, but not for the knowledge itself. So it's vastly different from just describing what you actually want to do. It's one of the most efficient token. It's one of the most token efficient pieces of context engineering there is, and that you can use. But keep that mechanism in mind in general, a short key that leads to a large body of knowledge. Because we'll meet that same move again later with one difference where the knowledge lives. So that's the mechanism. Now we move on to the practical part. And the most popular anchor people reach for is role. So, and with this practical part, I will give you the, you will get the grip on the options and on the patterns behind basically most of the tools out there. And everything from here is based on context engineering and practice. So what goes into the context window, what stays out, and where it sits. So like I said, a common first move would be for a task, you're an expert security engineer, review this code. And it's worth checking if that actually helps. So there was one study, they used over 100 personas across 2,000 factual questions, and they let it run a prompt containing a persona, didn't beat having a persona at all, or just choosing a random persona. So the whole persona thing didn't have an effect on the factual correctness of the response. So why is that? The question already tells the model the topic. You asked it to review code for security, and the role mostly restates that. A precise term would be different. It adds the part or the question left out. For example, threat modeling with Stride, the OWASP Tapton, least privilege. Each of those pull in a method that the bare role never named. So an assigned role moves the voice. For example, in your output, it maybe gets more or less descriptive based on the role you assigned. While the exact term you can use, the semantic anchor, moves the facts. Which means if you have the choice or have to make a choice, you should always spend your words and your tokens on terms and not on roles. So basically the term wins, but what happens if you don't know the term? So here's the catch with all of that. The expert knows to type London TDD, but if you're not in the field, you can't. You just simply don't know the term exists, and this is true for every domain-specific field. You are not a domain expert in everything, and you don't have to be. The model, however, does know the term, so it holds the term even when you don't know it. So the better move is you run a short pre-session first and ask it, what are the name frameworks, key terms, and trade-offs an expert would use for this? List them for me. And out come your possible semantic anchors you can then use. You can carry those exact terms into the real session and they will be used as described. So one caution while you're assembling that prompt that actually should do a task, there's an effect called context rot. You've already seen it on the accuracy meter I shown previously. The fuller the window gets, the worse the model reads it. And any irrelevant context steers these context rotting. Because an off-topic passage doesn't just waste space if it actively drags the accuracy down. So in general, trim what the task doesn't need if you're doing an initial prompt. And if you're just in the middle of something, you can tell the model to ignore it. That at least recovers part of the loss you will otherwise suffer. So the sharper words are the fraction you can control. But Everyone has had the one session or multiple sessions where the model stops listening anyway, and that's where we get next. In such a session, the model loses the thread. It ignores sometimes you told it something that in like 10 minutes before, and it forgets a thing it should clearly know. So let me show where that instruction actually lives. So you wrote just the tip of the iceberg, your prompt. Below the waterline sits the system prompt, injected project files, and also the tool listings the agent has. And the biggest layer, the one that keeps growing, is everything the session has already accumulated. So every file it read, every tool result, every earlier turn. So your instructions from turn 3 isn't gone. It's still down there, competing with everything else and slowly drifting into the middle, where the recall is worst. What you're looking at is a context window from earlier, filled up for real this time. So when a model forgets something, don't ask what's wrong with the model, ask what's in the window. And if you want to have fun, go to Reddit and tell it people who say, oh, our model degraded, it's totally horrible and it's totally stupid. And that gives you two rules. So don't keep everything always loaded, because every always on file sits below that waterline on every single turn, and you pay for it in attention and not just in tokens, whether it's used or not. What you should do is package your knowledge and load it when it's needed. So the always on part stays as lean as possible. And there's a mechanism exactly built for that. And this is progressive disclosure. This is also what this slide describes conceptually. And it just means that information is shown to the model when it's needed instead of all upfront. And there's also something that does exactly that, a standardized format, skills. Skills are a concept that made it into a standard, fortunately, and it's the tick from the iceberg shaped into a mechanism. So upfront, only a description loads. The model starts with a row of names and one-liners as description, and the full skill body enters the context the moment it becomes relevant. And notice what the one-liner here says, and tells the model when to use the skill and not what the skill does, because the model matches it against the task at hand, and and if the description is what it does, the model would still have to interpret that first, and it will most likely not do that. So it won't invoke the skill. So, and inside the loaded skill, we have that same move again. Or at least we can use it there. So information and specific instruction can sit inside reference files, separate files that contains knowledge, and also instructions, for example, for subtasks. And they only get read at the point where they're really in use. So if the skill contains a workflow and you mention at some point in the workflow, not at the beginning, a file, then this file will be read only when the whole workflow is really at that point. So why does this timing even matter at all? That comes straight from what we've already learned. The model rereads everything every turn. It reads the edges and skims the middle, and the window degrades as it fills. So when something enters the context, the context decides how much attention it gets. And it's basically the same economy as an anchor. A lot of relevant context is bought pretty cheaply. The difference to the semantic anchor is that the anchor is a key into the model weights, into the model's trained knowledge, while a skill loads actual text into the context. Yeah, and the thing that gets loaded is almost nothing. It's a markdown file with a bit of front matter and a few lines of instructions, no framework, no SDK. A few, honestly, can actually be up to 500 lines or even above that. But as we've always learned, the less the better. So keep the main skill file as short as you can, and it usually will work better. So, but how do you build a skill that holds in your day-to-day work? So it mostly comes down to a few do's and don'ts. When the skill is a workflow, which is, from my experience, the best kind of skills you can create, the main thing is to make the structure as explicit as possible. Because the model will rationalize past anything soft. So don't use anything like if you feel like it, okay, this is an overstatement, but if you feel like it, do this or that additional task. Or if this answer is not sufficiently good, give another answer. Things I actually read and skills I reviewed. So the do is each step produces what the next one needs, and you can even introduce branches and also stop conditions and validation gates. These should be spelled out as real decisions in that workflow. So let's take this one. A change gets drafted, the tests fail, it gets revised, and after the third failed revision, the workflow stops with an explicit error. It doesn't loop forever, it doesn't quietly degrade into a best effort. And note where the stop sits here. It hangs off a failure branch and is not part of a happy branch here. So this, of course, means don't do the opposite. Don't use terms like try to verify or avoid mistakes or the famous make no mistakes. These are often just interpreted as suggestions. And if you introspect ever a model a failure in the behavior, then you will see things like, yeah, okay, I thought it was fine, and just skip the step. By the will, skills come in two shapes. I already explained workflows. There are also knowledge blocks, and knowledge blocks are much simpler. It's basically just bundled information that is useful for a specific task. But they are still very useful, especially for sharing knowledge about any topic inside a team or also on GitHub. And it gets especially valuable when this is real domain expertise. So something people usually just don't know. They can just load the skill. They can, of course, also read it to learn something new. That's always a good idea. And then they can load this specific domain knowledge into their prompt and into their workflows. But workflows are the things that are really to design. The structure of this workflow decides what a skill does in the end, but you will likely still get it wrong the first time. Everyone does, I does as well. And now we will see how we can fix this. As I said, skills don't work initially perfectly fine. And they get good over a few cycles. And for that, you have to run the skill and see where it misbehaves. So we usually know that already from software development. You have to actually use your application to see what doesn't work. But in software development, we are much more used to creating any kind of automated tests for it that can and should be done for skills as well. But the improvement works best when real people use it for their real tasks and report back what didn't work. This includes yourself, of course. So, how can you then improve the skill? You can apply gap analysis if there's really something missing here. Or you can ask the model that ran the session to introspect itself if it missed something. And this is a pattern that actually works extremely well. You have to force it a bit out of a model. So if it misbehaves in any session and you say, oh, you did a mistake here, it will usually be like, okay, sorry for that. I will correct it right away. But that's not what you want. You want to know what happened here and why there was any kind of misjudgment. And there you have to put a little pressure on and say, I don't want apologizes. I don't want this corrected. I can do that myself. Just be transparent about what you thought and what you did. And then usually you will get really good answers that, because it turns out, if you force them, these models are usually very good at introspecting their own behavior out of their existing context. This can then be used to apply a fix to the skill. You can then ask a different session, hey, this is the skill, it misbehaved like this, the result was wrong, the result was not as good as intended, and this is the introspection from the model that ran it. Have a look at the skill, what went wrong, and then fix it. And this is how you iterate skills. What you should never do is, and that's a common beginner problem, just guess a fix or ask Claude or ChatGPT, hey, this is the skill, fix it. Something didn't work. And even if you are specific, then you might not guessing it, but a model will still guess what went wrong. So then diagnosis is the last piece here. And we put everything together. Working with skills comes down to 4 habits. So the first habit you should learn is just create them. The third time you find yourself doing something in the same way, that's the tell that a skill is waiting there just to be created. And because a skill is only a markdown file and you will most likely ask the model itself to create it for you, it's cheap to make. And it's also cheap to delete. So don't deliberate over whether it deserves to exist or not. Just capture what you've done. You can use a session transcript for that, and delete it later if it earned nothing for your workflows. The second habit is to design skills as workflows. Remember the flowchart from 2 slides back with the steps that feed each other, the explicit branches, and also the explicit stops. And one side note here, please read the skills yourself. Don't trust that the model will do everything right because they used to handle skills just because they are markdown files as human-facing documentation. So they often start to babble in there. They start to explain themselves. They start to write historic context, why this was created. And this is nothing more than simple context load. It doesn't add any value for the workflow itself. So read them and you will likely see something that shouldn't be there. So the third one is skills should fail hard, not soft. So when a skills hits something it can't handle, for example, you ask it to perform a web research or to do a deep research or something like that, and it can't access any website. The models really tend to say like, oh, okay, I got this snippet from Google and it gives a summary and says like that, so I assume this is the actual content and we'll go on to the next one. Even if the actual content is totally different. So large language models are in this kind of behavior very prone to falling for clickbait as well, like we are. And that's why you have to tell them, stop. If you encounter this or that problem, just stop the work, be transparent about it, and you can always tell them to use you as a human as another tool. So if it can't access any resource, tell the model upfront that it should stop there and ask you to provide the information. It won't do it 100% of the time, but it will do it more often compared to when you just let it work. So, and this is because it's for a model always a tempting alternative to just to continue. So they have this behavior baked in that they want to make the user happy. They want to finish a task because that makes the user happy. And often they want to do the task fast because that also makes the user happy. At least they think that. And it seems like Anthropic and OpenAI think that as well. They try to mitigate this behavior by now. So as we know from software engineering, quite degrading is one of the worst enemies you can encounter. So imagine a shop system where the calculation of any discounts didn't work, and it's not made transparent that it didn't work, but just things are calculated differently. And if anyone reviews the invoice, then nobody has an idea why the hell the numbers are diverting. So this is basically the worst that can happen, and you can see this in workflows as well. So just tell them always fail hard and be transparent about it. And the fourth one is, as I said, diagnose them and then iterate. Every failure of a skill or of any workflow, of any tooling you've used, is actually a new input. It's very valuable for you because it shows a new direction and it shows an improvement path. Note it. If you can't do the diagnosis directly, for example, note the transcript UUID or export the transcript, and you can handle that later. And if you are at this point, let the model introspect itself why this happened, and then you can ask in another session just fix it. Basically the loop from the last slide. So, and with these 4 habits, you have a lot in your hands to get a grip on your day-to-day work with any kind of AI tooling. I talked a lot about skills here, but this basically boils down to context engineering and to what the capabilities of any agent of the runner are, what it can access. And with this in mind, you can already you understand better what the failure modes are and how you can fix them. So, and if you mastered that or are bored of it, whatever comes first, you can still go a lot deeper. There is a lot more to learn. The tools that are at hand depend on what agent you use. You can use skills and just create more skills and just also be a bit brave about them. So if you encounter any workflow you think this is too complex for a large language model, just try it out. Maybe give it an afternoon. It won't be wasted time. You will have learned something about it in the end, and just give it a try. You can use hooks. They are a part of Claude Code. I think Codex introduced them as well recently, or a couple of months ago. And these also reveal very nice possibilities. For example, you can create extension points for skills and other tooling. And you can enforce certain behavior to make your workflows even more strict. You can use sub-agents to isolate context. They can take focused tasks and hand back clean results. So basically context engineering on an architectural level. And it's all the same model, just with more blocks. And when you go beyond that, and I encourage you to do that, don't stick just with coding. And this is also how I advertise this talk. Everything you've learned here doesn't only apply to coding. You can do it for basically everything. You can just try it out. Let me give you an example. I helped a pharma lab once, and with my help, they ran an AI-supported root cause analysis on this exact same pattern with the same iterations for improvements. The workflow itself was completely agnostic. There are already established frameworks for root cause analysis out there, and I teach the skill them. And the human that used it plugged in the domain, they gathered data, they ran experiments, and the AI proposed directions but it never played the domain expert. This is something you also have to enforce. If you don't want any kind of AI tooling to play the domain expert, you have to say it to them, to it very, very strictly. The part that mattered most stayed human there, and this workflow, in the end, surfaced directions even the company specialist hadn't considered. So it really showed them how they could tackle a problem they didn't encounter before, and it made the root cause analysis a lot more efficient. The specialists knew pharma, so this wasn't the reason, but it just worked because the workflow itself was sound and the humans fed it well. And this goes beyond that. Manufacturing, finance, you name it. It's the same move everywhere. So try the things you don't think are possible. You might just be surprised in the end. So, what all of this buys you, hopefully, is an assistant that works with you and not against you for code and for everything else. And this is why it's called a pattern, not a tool. A lot of the principles I've shown you here can be found in the Shopware Labs AI coding tools repository. And don't only look at the current state there, have a look at the changelog files as well. So it's in the core still a Claude Code marketplace with installable plugins. The skills itself are mostly compatible also with any other agentic tool. Because it's standardized by now, and the change logs of the single plugins and skills will show you how they were iterated, how they were improved, and often they also contain a lot of information what the specific failure mode was at any point. Yeah. So now I'm finished, and I'm open for your questions.